So this is my SDL for week 5, which is on resolution and efficiency. And basically I'm just gonna give a brief overview of what efficiency is. So the efficiency of a chromatographic peak is a measure of the dispersion of the analyte band as it traveled through the HPL system and column. So basically you're looking at how wide the width of each peak is, which means the evaluation of band broadening is crucial when judging efficiency. As you can see, for low efficiency, the peaks are harder to be seen as separate peaks, and in high efficiency, they're much more narrow. So an equation that includes the main factors contributing to column band broadening was developed and is known as the Van Deemter equation. So it has H equals A plus B divided by U plus UC, where H is height equivalent to theoretical plate, so the theoretical plate's height. U is linear velocity, A is eddy diffusion, B is longitudinal diffusion, also known as molecular axial diffusion, and C is mass transfer. And I'll just give a brief overview of what these factors are. So eddy diffusion, it relates to the fact that an analyte molecule within a band of analytes can take one of many paths through the column. So this multiple path effects tends to make the band of analytes more broader as it moves through the column. Longitudinal diffusion is caused by tubing length being too long or maybe tubing that is too wide. And mass transfer, so the stationary phase material is porous and the mobile phase within the pores is stagnant. So there will be analyte molecules that enter the pore, those that don't enter the pore, and those that penetrate more deeply into the pore, resulting in them being held up at different extents, thus causing broadening of the band. And the second learning objective asked us to establish the relationship between efficiency and resolution. So as you can see in this equation, efficiency is definitely a factor of resolution. And here I'll show you a diagram and to explain a little bit more about this. So this is a slide that's thanks to Ardent, and as you can see at a low efficiency the resolution is 90.95, and as you increase it the resolution also increases as well as the plates, and then until you get high efficiency where both of the peaks are very narrow, and then you have the highest possible resolution compared to the other values. And you can also see that the plate value also increased. So with this diagram you can definitely tell that efficiency is a factor that affects resolution. And in knowing all of this, for our next HPLC experiment, maybe to get our desired 7 peaks, we could use a column that isn't too long in length. It has to have a high number of plates and contains the smallest particle size possible, and it might be possible just to get the 7 peaks. And thank you for listening. That's the end of my SDL.